Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S2 9709 component 62 of November 2020. And for this, I am using the work of an outstanding and one of my best student, Miss Iman Anwar of class 2021, the Lyceum. Well, all instructions are very important, especially these two. You must show all necessary working clearly. No marks will be given for unsupported answers from a calculator. And this last one as well. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Well, must follow all these instructions and always go through the instructions before starting the paper. Advices: do neat and tidy work, avoid careless mistakes, read the questions carefully. Question number 1. On average, 1 in 50,000 people have a certain gene. 1 in 50,000. This is the P of binomial. Use a suitable approximating distribution. This is the Poisson approximation. Because when the P of binomial is less than 0.1 and n is greater than 50, then we always use Poisson approximation to binomial distribution. Find the probability that more than 2, greater than 2, in a random sample of 150,000 have the gene. This is the n of binomial. So this is the binomial distribution. N is 150,000, whereas P is 1 upon 50,000. So we can easily get the value of NP. So NP must be 3. And this NP will become the lambda. It's here. Lambda is 3. N, this is N and this is P. More than 2 means 1 minus 0, 1, 2. You all know we write more than 2 like this. Since Poisson distribution is an infinite distribution, so we are unable to find more than 2 probability with direct method. 3, 4, 5 till infinite. So we have to use indirect method, which means 1 minus those numbers which are not in this list. 2, 1 or 0. This is the way to find probabilities in Poisson distribution. Make sure your concepts must be very good of all the topics before watching the lectures of yearly sort papers. So more than 2 is 1 minus 0, 1, 2. And this is the way we find probability in Poisson distribution. We take E common, E power minus lambda, and lambda is 3. And this one is for the 0. This is lambda power 1 over 1 factorial, and this is lambda square over 2 factorial. And must give your answer up to 3 significant figures. Question number 2. A 6-sided die has faces 1 to 6 when the die is thrown 300 times. This is n, and this is the basically question of sample proportion. It shows a 6 on 56 rows. See, 56 over 300 will give you proportion, sample proportion. Calculate an approximate 96% confidence interval for the probability that the die shows a 6 on 1th row. This is so simple. If you remember the formula of confidence interval of population proportion, you can easily do this. So PS plus minus Z PS QS over NS. You must know this thing. PS follows normal when n is greater than 30. Here we write PS QS over NS. If you know this distribution, you can easily make this formula. So PS is here, Z, and this is the standard deviation. This is the variance and this is the standard deviation. You just need to substitute the values. 96 means 98%. This is 2% and this is 96%. So this total area will be 98%. So this number is 2.054. So PS is here. Use the fractional value instead of decimal value because fractional value is more accurate than the decimal value. Z is here, 2.054. PS QS over NS. So PS is this, QS will be 1 minus this. That means 61 over 75 and NS is 300. So give your answer up to 3 significant figures. This is the required confidence interval for population sample proportion or population proportion, you can say. The important thing is this, and with the help of this, make this formula and write and take out the correct value of Z from either use your, from calculator or table. You have option, you can either use your calculator or table. Next point. M claims that the die is biased. Biased means the probability is not 1 upon 6. When die is fair, then the probability of all numbers must be 1 upon 6. Use your answer to part A to comment on this claim. See, 1 upon 6 means 0.167 and this number lies in this interval. So 1 upon 6 means the die is fair and 1 upon 6 in decimal is 0.167 and this number lies in the confidence interval. That means the die is fair. You have to reject the claim of M. Since 1 upon 6 lies in the confidence interval, so reject the claim, or there is no evidence that the die is biased, or simply reject the claim. So if the number lies in the confidence interval, you have to accept the, reject the claim because the claim is the die is biased and 1 upon 6 means fair and 1 upon 6 lies in this, so this die is fair. Next question. This is the question of PDF, probability density function. A random, and this, if you see, this is the straight line function. So the triangles, this triangle from 2 to 3, this one, and this total triangle, complete triangle, the large triangle, they both are similar. This triangle has base 1 and this triangle has base 3. So when we have straight line PDFs in this form, then triangles are similar. We can use similar triangle method to get the probabilities. A random variable x takes values between 0 and 3 only. See, this is bold and this is also bold. This means this PDF is defined from 0 to 3 only. And after 3 and before 3, this PDF will be 0. So this f of x is defined only for these values of x. If they ask you make a sketch, then you must bold, you must show this part and this part as bold lines. Now show that C is 2 upon 3. This is so simple. C is the height of this triangle. So you know the area of this total triangle is 1. So by using this formula, we can easily get this C, or we can easily prove this. So since we know area is 1, area under the curve is 1 because this is PDF and total probability is 1. So area must be 1. So half base into height shown. show the neatness, show this, check this neatness. This work is extremely good, really neat work. Try to do neat and tidy work, because presentation is very important. Now we need this probability x greater than 2. So this triangle from 2 to 3 and this large triangle, they both are similar. So this small triangle has base 1, whereas this large triangle has base 3. So we can use area of similar triangle. A1, A2, L1, L2. This triangle means A1 and its area is P. So P, large triangle, this triangle has area 1 and base 3. So 3 here, and this triangle has base 1, this one. So this area is 1 upon 9. So by using area of similar triangle, we can easily get this probability. Now we need expectation, and for that we must have the equation of PDF. We must have equation of this line, and you all know how to find equation of this line. This is so simple. It should be f of x mx plus c, and c is 2 upon 3. You just need to work for m. M is minus 2 upon 9. So we can easily get the equation of this PDF now. Here is the equation of this PDF. And the formula of mean is this. X, f of x dx, all x. You all know this formula. All x, f of x dx. So f of x is this. So multiply this x with f of x. This is the simplified form. Now we can easily integrate this function. You all know how to integrate this. This x square will become x cube upon 3, and this x will become x square upon 2. Now apply these limits and get the answer. Expectation is 1. Next question. The areas x centimeter square of petals of a certain kind of flower have mean mu. In the past, it has been found that mu is 8.9. Mu is 8.9. This is H naught. Following a change in the climate, a botanist claims that the mean is no longer 8.9. That means mu has changed. Change means H1 has not equal sign. So mu has changed. You can write here in bracket mu is 8.9, mu has changed, or mu is not 8.9. Well, the areas of a random sample of 200, this is the sample size, from this kind of flower are measured, and the results are summarized by. So these results are for unbiased estimates of population mean and population variance. Test the botanist's claim at the 2.5% significance level. Since we have not equal sign in H1, we are looking for a change in H1. Therefore, we have to perform a two-tailed test. So this should be 1.25 here and 1.25% here. And the value is 2.241. Now first work for unbiased estimates. Mu cap. This is sigma x over ns. Its value is 9.25. Sigma cap square. This is the formula of sigma cap square. You must know this formula. By substituting all the values, we have sigma cap square. And this is the value of z. Now work for z test. Z test is test value. This is the test value. Sample mean is always the test value. So write the test value, this value here. This is mu naught, and this is the variance, standard deviation. So 3.706 divided by 200. This is the formula of C. The test value minus mu naught over sigma cap square over ns. And make sure you write h0 and h1 correctly. First write h0, then put two dots and then write mu. Since you are working for mu, you are testing mu, so write mu here and mu here. Now z test is 2.57, which means this lies here. This lies in critical region. So we have to reject h0 and we have to accept h1, that mu has changed. Since 2.57 lies in critical region, therefore h0 is rejected and the claim is accepted that mu is not 8.9. So whenever z test lies in critical region, we reject h0 and we accept the claim. Next question. Customers arrive at a shop at a constant average rate. So two conditions are missing of Poisson. They are coming independently and randomly. State another condition for the number of customers arriving per minute to have a Poisson distribution. They must arrive independently and randomly. You can write anything. Independently is better. 2.3 per minute. This is lambda 2.3 for 1 minute. It is now given that the number of customers arriving per minute has the Poisson distribution. Find the probability that exactly 3 customers arrive during a one period. So lambda is still 2.3. And exactly 3 means e power minus lambda. This is the formula. Lambda power cube over 3 factorial. Next part. Find the probability. Make sure you give your answer up to 3 significant figures. Find the probability that more than 3 customers arrive during a 2-minute period. Now you have to change the value of lambda by using ratio method, and lambda will be 4.6. Because for one minute lambda is 2.3 and for 2 minutes lambda should be 4.6. More than 3 means 1 minus 0, 1, 2, 3. This number is exclusive, so it must be inclusive here. Make sure you write the correct list here. Now take e power minus lambda common. Lambda is 4.6. This one is for 0. This means lambda power 1 over 1 factorial, lambda square over 2 factorial, lambda cube over 3 factorial. And this is the answer up to 3 significant figures. Next part. Find 5 1-minute periods. So n is 5. 1 minute period means lambda is still 2.3. Find the probability that no customers arrive during exactly 2 of these 5 periods. This is the binomial situation. No customers arrive during exactly 2 of these 5 periods. 2 of 5 no customers. You have to solve this question through binomial. It should be 5c2 p power 2 q power 3. Now this information will help you to find p, no customers. So no customers is here, 0, none, and none means e power minus lambda. So this is p, and q must be 1 minus this, because q is 1 minus p. So you have to write p here, meaning e power minus 2.3 here, and q here. It's here. This part is important. First find p through Poisson and then use this p in binomial. You can take the screenshot of this solution if you want, because this solution is very important. This part is very important. Question number 6. A biscuit manufacturer claims that on average 1 in 3 packets of biscuits contain a price offer. This is the manufacturer's claim. 1 in 3. Packets of biscuits contain a prize offer. Jerry suspects that the proportion of packets containing the prize offer is less than 1 in 3. So H1 has a lesser sign. The proportion is less than 1 upon 3. And this is the manufacturer's claim that proportion is 1/3. In order to test the manufacturer's claim, he buys 20 randomly selected packets. This is the binomial situation. It's here. 20 packets, and he finds that exactly 2 of these packets contain the prize offer. This is the test value. And this is a lower tail test, left tail or lower tail. So H naught must mention clearly that this is the binomial situation and we must have P here. Normally students don't write H naught and H1 correctly. First write H naught, then put 2 dots and then write P. 1 upon 3. Less than 1 upon 3. This means manufacturers claim that proportion is 1 upon 3, and this means proportion is less than 1 upon 3. By the way, when you accept H naught, then you can make type 2 error. And this H1, when you accept H1, this could be type 1 error. So H naught, when your decision is accept H naught, when you accept H naught, then type 2 error can be made. And when you accept H1, then type 1 error can be made. So you can write these things here because in this question they will ask type 1 and type 2 error maybe. For this part, just focus till here. P and P. P is less than 1 upon 3 and P is equal to 1 upon 3, H naught and H1. 10% is here and test value is 2. So you have to find this probability, x less than equal to 2, because test value is always inclusive. Now this probability is less than 10%. That means your 2 lies in critical region. That means you have to reject H naught, meaning the manufacturer's claim is rejected. Rejection of H naught means you are rejecting this fact. There is no evidence to support the manufacturer's claim, or reject the manufacturer's claim and accept this thing, that proportion is less than 1 upon 3. Part B. Maria also suspects that the proportion of packets containing the prize offer is less than 1 in 3. She also carries out a significance test at the 10% level using 20 randomly selected packets. She will reject the manufacturer's claim if she finds that there are 3 or fewer packets. So H naught will be rejected. If x is less than equal to 3, so this is the critical region. When you reject H naught, then that region is critical. I mean, whenever you are here, then you reject H naught. So critical region is x is less than equal to 3. Find the probability of a type 2 error. So here we find the probability of type 2 error. This is the region for type 2, the acceptance region. This is the critical region, and this is the critical region complement, or you can say the accepted region. So type 2 error is here. For type 2 error, you need to find this probability. X is greater than 3. Type 2, critical region complement, which is x greater than 3, because critical is x less than equal to 3. So critical complement must be x greater than 3. And we must have a new p for type 2 error, and this is the new p. Is actually 1 in 7. So this is the p. So find this probability. And you all know how to find this probability. It should be 1 minus x less than equal to 3. Indirect method. And must give your answer up to 3 significant figures. This is the region of type 1 error, and this is the region of type 2 error. Type 2 error means critical region complement, and this is the critical region. And this is type 2, meaning in context. Concluding, manufacturer's claim that proportion is 1 in 3 when it is actually less than 1 upon 3. Explain what is meant by type 2 error in this context. So you have to explain type 2 error from H naught with the help of H naught. Here is H naught. You have to say concluding that proportion is 1 in 3 when it is not, or when it is less than 1 upon 3. Concluding that proportion is 1 in 3 when it is actually less. Always explain type 2 error with the help of this information. Always say this thing, concluding that proportion is 1 in 3 when it is actually less. Now I will discuss the solution of last question after the adhan. Allahu Akbar, Allahu Akbar. Allahu Akbar, Allahu Akbar. Ashhadu an la ilaha illallah. Ashhadu an la ilaha illallah. Ashhadu anna Muhammad Rasulullah. Ashhadu anna Muhammad Rasulullah. Hayya ala falah. Hayya ala falah. Hayya ala falah. Quwwata illa billah. Allahu Akbar, Allahu Akbar. La ilaha illallah. La ilaha illallah. Muhammadur Rasulullah sallallahu alaihi wa sallam. Amin. Sallallahu alaihi wa sallam. Allahumma rabba hadhihi. Now, last question, number 7. Before a certain type of book is published, it is checked for errors, which are then corrected. For costing purposes, each error is classified as either minor or major. The number of minor and major errors in a book are modeled by the independent distributions normal. This is for minor errors and this is for major errors. You should assume that no continuity corrections are needed when using these models. A book of this type is chosen at random. Find the probability that the number of minor errors is at least 200 more than the number of major errors. Means this thing. Minor errors at least 200 plus major errors. So you need to bring these two information on left side of this inequality and you'll get this thing. Now first work for their mean. So write E of this and then V of this. So this will become EM, which is 380. This will become minus E capital M, which is 210, and we write constant as it is. Number 2, in variance, make sure you write variance of constant 0. So variance of M, 140. Variance of capital M is 80, and this is 220. Now work for this probability. M minus 200 greater than 0 or greater equal to 0. Since this is the continuous distribution, so these signs mean same thing. See, this 0 is here, this mean is here, and this variance is here. I mean, square root of variance, because we write standard deviation here. Give your answer up to 3 significant figures. The last part of this question. The cost of correcting a minor error and a major error are 20 cents and 50 cents respectively. So the total cost, 20 times small m minor and 50 times capital M major. So you need to work for their mean and variance. So for mean, E20m, E50m, and this. See, these numbers are multiples. Because if you are correcting one error, so 20 times 1, 20 minor, I mean, if there is just one minor error, so 20 times 1. Let's suppose there are 100 minor errors, so 20 times 100. So these numbers are multiples. So make sure when you will work for variance, you must square these numbers. Like here. 20 square, 50 square. These coefficients are multiples of this m and this m. So find the variance correctly. This is sigma square. Now find the probability that the total cost of correcting the errors in the book is less than $190. We need this probability. Total is less than $190. And this is in cents. Make sure you read this thing carefully. 20 cents, 50 cents. So this must be in cents is 19000. So this is the requirement. Mean is here and standard deviation is here. And give your answer up to 3 significant figures. An important advice for me and for everyone: think before we speak. Think before you speak. Good luck. Allah Hafiz.